Another example of dual-side mechanism is the reaction between two adsorbed species. So in previous slide, the reaction will involve only one adsorbed species and another vacant site to produce the product. Okay, for this example, the reaction involves two adsorbed species, meaning that you will have two reactants and both reactants will absorb on the active site of catalyst. Okay, the first example here, A.S plus B.S. So meaning that during the absorption reaction, species A, reactant A plus S will produce A.S. Okay, so that is the first adsorption step. And the second adsorption step is B plus S will produce B.S. And both adsorption reaction is reversible reaction. And then during the surface reaction, so A.S will react with B.S to produce two products, which is C.S plus D.S. Okay, so if you look at the diagram here, so the first diagram, B and A attached to the triangle active site, and then surface reaction occur and it will produce product C and D that attach with the active site. Okay, then another example, still for two species, for two adsorbed species, but at different type of active site, which is site S and phosphophy S. What is the difference between active site S and phosphophy S? Shape of the shape of active site, which is the absorbed species B attached to the active site rectangle active site, and absorbed species A attached with the triangle active site. And the reaction will occur to produce product C that attach to the rectangle active site and product D that attach to the triangle active site. So that's the difference for different type of dual side mechanism. So first, one adsorbed species, but the product produced at different active site. The second one, two adsorbed species. So kalau two adsorbed species bermaksud adsorption step ada dua. Adsorption step 1, adsorption step 2. Adsorption step 1 for the adsorption of species A, adsorption step 2 for the adsorption of species B. So bila ada two adsorbed species, automatically dia akan jadi dual side mechanism reaction with two active site. Alright, so similar for reaction to two species but different type of active site. So ada tiga example of dual side mechanism. Okay, then the next one is Illy-Rideal mechanism. So what is the difference of Illy-Rideal mechanism between the single site and dual site mechanism? Okay, Illy-Rideal mechanism, the reaction between an adsorbed molecule and molecule in the gas phase. Okay, so apa beza dia? Right, you have two reactants. Okay, so A plus B will produce the product. That's the overall reaction. So meaning that you ada dua reactant. Okay, one of the reactant, which is A, will adsorb on the active site, but not for B. Okay, so B maintained as a gas. So this is an example for gas phase reaction. Okay, so species A, only species A adsorb on the active site of catalyst. So that's why during adsorption, A plus S will produce A.S via reversible reaction. Okay, so during the surface reaction, so the adsorbed species A dot S will react with reactant B. So bermaksud only one reactant sahaja yang adsorb, another one only involved in the surface reaction, which is B. So B maintained as a gas. So adsorbed species A dot S reacted with gas B to produce the product. Then the reaction will occur either reversible or irreversible. So to produce the product C dot S plus another gas D. But sometimes only the product, tak ada another gas D tu. So it can be A dot S plus B in gas phase, reversible reaction or irreversible reaction C dot S. So kalau only product C, D will be removed. Okay, so if you look at the diagram, only A attached with the triangle surface, active surface. Okay, then B, dia as a gas, dia tak attach with mana-mana active site, and then reacted to produce the product C. So RS equal to KS bracket CA dot S PB. So the rate law for B, we express it in terms of partial pressure of gas B minus C dot S PD. Kalau ada produce gas D that not attached to the active site, so in terms of partial pressure D, divide with KS. Okay, so that's why the Elie-Riedel mechanism ni special. It's actually Elie-Riedel mechanism not under the Lamur-Hisham-Wood. Lamur-Hisham-Wood is the mechanism of reaction, either it is single site mechanism or dual site mechanism during the surface reaction. But Elie-Riedel different from the Lamur-Hisham-Wood. So Elie-Riedel, during the surface reaction, the adsorbed species reacted with gas. So that's the difference of Elie-Riedel with single site and dual site mechanism. Okay, and finally the desorption step. Okay, after the product produced during the surface reaction, okay, so the product still attached with the active site. Now, during the desorption, the product will detach from the active site. So the product of the surface reaction absorbed on the surface are subsequently dissolved into the gas phase. So maksud product produced during the surface reaction, product attached at the active site ataupun on the active site. So dia dalam bentuk C dot S, the product C. Then desorption reaction occur via reversible reaction. Okay, so desorption always reversible, similar with adsorption step. It's always reversible. So except surface reaction, it can be irreversible or reversible. Right. So C dot S, reversible reaction, it will produce C plus S. So the product in gas phase, C plus S. So S ni adalah vacant active site. Therefore, the rate of desorption, okay, RDC. So RDC bermaksud rate of desorption for product C ataupun for species C is equal to KD, rate constant of desorption, bracket C dot S, concentration of your product that attached with the active site, minus PC. Sekarang your product after desorption dah dalam bentuk gas. So that's why we express the product C in terms of partial pressure of C. Multiply with CV because from the mechanism of reaction, we leave the vacant site S. So the concentration is CV. Divide with KDC, equilibrium rate constant KDC. Apa? KDC is the equilibrium rate constant for desorption of C. So capital K DC. Then desorption equilibrium constant is reciprocal of adsorption equilibrium constant. So meaning that the KDC equilibrium rate constant for desorption of C equal to 1 over equilibrium constant of adsorption of C. So, rearrange the rate of desorption as the equation in yellow table. So, kita ganti masuk je 1 over KDC from the rate of desorption equation to as a 1 over KC. And then rearrange, you will get the equation in the yellow table. So, dapatlah equation as RDC, rate of desorption of C, equal to KD, rate constant of desorption, bracket C dot S minus KC PC CV. So, capital KC ni adalah equilibrium constant for adsorption of C. Okay, that's all.